Okay, so real quick, the test, remember there's two tests. It's really just one test broken into two small tests. Test 4 is going to be the non-technology test. Let's click them all closed. That's the one where you're not going to have access to Desmos matrix or graphing. All you get is Desmos scientific. Test 5 is the technology test. So the first test, let's look at test 4 first. We'll just go through all the different kinds of questions really on both tests. So on test 4, questions like this. If they ask you, is the ordered triple -9, 8, 3 a solution of this linear system, how would you check?
Put it in a matrix.
Well, I mean, you could, but you don't have to. You could plug them in. Absolutely, just plug them in. Because you won't have a matrix calculator on test 4, right? So all you'd have to do using Desmos Scientific is just plug those values in for each of those 3 equations. Now you can just plug them in by putting parentheses and the numbers in. That's fine, that works. There is kind of a little shortcut trick you can do also. You could, in Desmos Scientific, you could type in x equals -9 and hit enter, and then it's going to store that value as x. Type in y equals 8, enter, and it stores 8 as the y value. Type in z equals 3, enter, and it stores 3 as the z value. Then what you're able to do is I could go to the first equation and I could just type in that expression and hit enter, and look what it does. It tells me that with those values of the variables, that expression is equal to 76. So it checks, right? So the first equation checks out. Second equation, I don't have to do anything different. I just go down and type in the left side of the second equation, and it tells me that its value, when these are the variables, is 23. So it checks out. Then I go down to third equation, and with those values of the variables that I entered.
Still replaced Chromebook.
Oh, they fixed it? Awesome, thank you. We get a value of -131 on the left side. Did it work?
No.
Did not work. Yeah, question? So you just literally type x equals -9 and then enter.
This is for test 4.
Test 4, yeah. You don't have to do this, by the way. You don't have to do this little trick. You could just do this, right? I could, if I wanted to, if you're not comfortable with that, you could take the first equation and just write -5 and in parentheses put -9 plus 5 times in parentheses 8 minus 3 times in parentheses 3. And it would tell you, if you did that, it would tell you 76. Okay? You can just do it that way if you prefer. The advantage of this is you only have to enter the values of the variables one time, and then you can just type in expressions with those variables, and you can get all the calculations quicker. So literally all you do is x equals 9, enter. Y equals 8, enter. Z equals 3, enter. And then just type in these expressions, and it'll tell you what the values are with the variable values that you already input or set. Okay, does that make sense? Okay, give me fist of 5 on that. We good on that? Okay. And again, you don't have to do that. You could just manually put the numbers in too. Okay, and so we found no, it didn't work because the bottom equation didn't work, right? That one failed. Okay, make sense? Okay. So solving a system with substitution. So here would be a linear system where substitution would be our best bet, right? Because we have a variable that's already isolated. So remember what I do. I'm just going to put a box around my substitution equation right away, and then I have to substitute into the other equation. So I plug it in there, right? And what's that give me? If I plug it in there, that top equation becomes x plus 11x is what I'm replacing with my y with, right? Plus 11x equals 24. What's x plus 11x?
12x.
So if 12x equals 24, what's x equal to? 2. There you go. 12 times what is 24? 2. Okay, so there's the first part of my solution. Where do I go to find the y value?
Plug it into the box.
To the boxed equation. That's why we put a box around it, because we're coming back to it. So we plug it in there, and we get y equals 11 times my x value of 2. So what's y equal to? What's 11 times 2?
22.
22. Okay, and then we get our solution, which would just be the ordered pair. X goes first, so we get 2 is our first number, and then 22 in our ordered pair. Give me a fist of 5. How are we doing? Good on that? Okay. Okay, questions? Questions? Okay. Okay, if you're not at a 5 yet, it's probably just because you haven't done the review yet, I bet, right? Is that it? If somebody's not at a 5 and they got a question they want to ask, I would take it gladly. Okay. Okay, so how about this one? This would not be a good candidate for substitution, would it?
Elimination.
We'd use elimination. Okay, now don't say anything out loud. I want you guys to look at this for a second and plan your strategy. So would it be, they both would work, but would it be easiest to eliminate x's or y's here? X's, yeah. Okay, so raise hands here. Somebody help me out. What would be one way to get rid of x's? Jalen, what could I do?
Multiply the top by 3 and bottom by -2.
Perfect. Okay, I want to get opposite numbers of x's. So if I multiply the top by 3 and the bottom by -2, that's going to work great. Because that's going to give me a positive 6x on the top and a negative 6x on the bottom, and those would cancel, right? So if I distribute the 3 all the way through the top, raise hands. Somebody help me out. What's that going to be? If I'm distributing 3 on the top. Well, why don't you guys all just tell me. If I distribute 3, what am I going to get? 6x
Minus 12y.
minus 12y equals 114. Now, if we could plug that in the calculator. It's 114. What about the bottom if I distribute a -2?
Negative 6.
-6x
Negative 10y.
minus 10y equals
Positive 40.
positive 40. Negative times negative is positive. And then look what happens. If I add those up, the x's cancel, which was our plan. Negative 12y minus 10y, negative 22y, and then that adds up to 154. So what's the only thing I have to do to isolate y here, everybody? Good. Divide. Good. Okay. So those guys cancel, and I get y by itself equals what that's just be -7 if we plug that in a scientific calculator. So I've got y equals -7. Now raise hands. To be brave, I'll need everybody to contribute a little something today. Where am I going to plug that to find x?
Probably top one.
Top one makes sense, doesn't it? Okay, it's a little bit easier probably. So we'll plug that guy in up here, right there. And that's going to give me 2x minus 4 times my y value of -7. And that's equal to 38. Okay, so that gives me 2x. Negative times negative is positive, so 2x plus 28 equals 38. So what are everybody together here? Everybody's contributing. What are the 2 steps in order to get x by itself? First
Minus 28.
oh, that's not everybody. I need everybody contributing. Subtract 28 and then? Oh, that's awesome. There we go. Okay, so we subtract 28. And we get 2x equals 10. So what's x?
5. X equals 5.
There we go. So we got 5 for x. We got -7 for y. So that's our ordered pair. Okay, fist of 5. How are we doing? Okay, good, good. All right. Okay, how about this one? Take a quick peek at that. Let's see here. Do I need to multiply both equations this time? Nope. Sarah, what would you multiply an equation by here? Which equation and by what?
The second one.
By, we're going to try to cancel the y's maybe? So multiply second one by what? Positive 2?
No.
But
Negative.
they need to add to 0, so negative 2 maybe? Okay. So if we distribute negative, top one we leave alone. If I distribute a negative 2 through the bottom, what's that going to give me?
Negative 6x.
Okay, negative 6x
Minus 2y equals
positive 2. Okay. Well, we canceled a little more than maybe we thought we were going to, right? We probably were targeting the y's, but look what happened. The x's canceled and the y's canceled. So what's left? What remains on the left side of my equation then if everything cancels?
0.
0, right? If everything goes away, I'm just left with 0. Equals 20?
Yeah, so it's no solution.
Yeah, so how do we interpret that? If I get a false, if the variables go away and it's a false statement, it just means
No solution.
no solution. There you go. Okay, what if we did all that same stuff and we got a situation where everything canceled on both sides and we got a true statement? What's that going to be, Avery? There you go, infinite solutions. It'd be, the two lines would be the same line, wouldn't they? Okay, fist to 5 on those two. That good? Okay? All right. Okay, the next part is really simple. This is on the non-technology test. So you're not actually going to solve anything because you don't have access to a matrix calculator, but I want you to just to show me that you can set up all the matrix stuff. So the first kind of question is just going to be, if I give you a linear system, I want you to write the matrix that corresponds to that linear system. And it even kind of tells you that it's 3 rows and 4 columns, which you could have probably gotten anyway. What would the coefficients all be in the first row? What do you think?
9, 1, 8, 9.
Okay, good. 9, 1, 8, 9. How about the next row?
8, negative 5, negative 1, 2.
There you go. Good job. And then finally the bottom one?
1, negative 5, negative 4, negative 4.
I like it. There it is. Piece of cake. How easy could it be? Now we'll flip it around and go the other direction. So this time they're giving you a matrix that corresponds to a linear system, and you got to write the linear system that goes with it. Okay, so what's the first equation going to be for this one? Mackenzie, what do you think?
2x y minus 2
2x plus y
minus 2.
minus 2z, okay, right, because that's the z column. Minus 2z equals 14. Everybody good with that? Okay, Madeline, next one. Okay, yeah, so what's that mean if there's a 0 there? Is there a y?
There's nothing.
No y term, good. So 4x plus 7z equals negative 1. Hey, phones, I said phones are supposed to be up front. So whoever's got their phone, please put it up front. Okay, bottom. How about the bottom equation? What's the bottom one going to be? What do you think? Marshall, bottom. What's that one? So what's that negative 1 mean? Negative 1 what?
X.
Okay, so negative x. What's next? Okay, so minus y. Good. We'll just leave it. And if it's a coefficient of 1, we don't even write it. So minus y plus z equals 4. Good. Got it. Perfect. Okay, fist to 5. How are we doing? Good, good. Okay. What about this guy? What if you use the matrix calculator and this is the result that you get? How do you interpret this? Is it one solution, infinitely many solutions, or no solution, first of all? One solution. What's your x value?
Negative 3.
Y value?
Negative 7.
Z value?
2.
Oh, man, you got this. Okay. What if you get that result?
No solution. Infinite.
Okay, it is infinite. Now, how do you know?
Because both 0.
Yeah, because that bottom line is the equation 0 equals 0, which is true, right? So it would be infinitely many solutions. Okay, good. What if you get that result?
No solution.
Okay, that would be no solution, right? How come?
Because there's not all zeros on the bottom.
Yeah, because the bottom row is false, isn't it? That bottom row means that's the equation 0 equals 6, right? 0x plus 0y plus 0z is just 0. And that's false. So no solution. Okay, good? All right. Next issue is graphing linear systems of linear inequalities. Let's take a quick look at a couple of these. And then that's it for the first test. First part for test 4. Okay, so here's the system of linear inequalities that we're going to graph. Okay, so now let's look at that top equation, or that top inequality. Y is less than negative 4x minus 2. So all you guys tell me here, like, raise hands. I want you to raise hands here. Nobody blurt it out. Is that boundary line going to be dashed or solid? What do you think? Jaylene, is that going to be dashed or solid? Dashed, good. How come? No equal sign, good. Okay, so we know we're getting a dashed line, so I'm going to go down to my graphing tool, pick a line, and make it dashed. Okay, can you guys tell me, in that top equation, what's the y-intercept? Negative 2. What's the slope? Negative 4 over positive 1. Okay, so then if I'm going to graph that, where do I start? On which axis? Okay, good. So I'm going to put a point at negative 2 on the y-axis. And Peyton, where am I going to go from there? I want to make my second point. And I'm asking Peyton. Down 4, and she told me correctly. Down 4, right 1. Okay, now am I going to, Daisy, am I going to shade above or below the boundary line on the first inequality? Below. Good. How come? Good. Y is less than my boundary line, which means I'm going below. So I would grab my paint bucket, and I would just put the paint bucket below somewhere. Good? Everybody good? Okay. On to the next part. Dashed or solid, everybody? Dashed. So I grab a line, make it dashed. What is the slope of the boundary line, second boundary line? 1 over 1. Rise 1, run 1. Good. What's the y-intercept? Okay, so then where do I start? Which axis? Okay, start at 3 on the y-axis, and I go up 1 over 1. Okay, perfect. Now, am I shading above or below? Above. I want the y values above the line. Okay, so now, is that shaded area in the right place then? No. It's not, is it? Because I want it to be below the first line and above the second one. So I need to move that. And all I have to do to move it is highlight the paint bucket and just move it up to there. And now it's in the right spot. Everybody agree? Yeah. Okay, good. All right, and we could check our work here. Actually, let me take a picture.
How do you move it?
You just highlight the paint bucket, and then I can move it to any place I want to.
Oh,
Okay? Okay, so there's our picture. Let's just see how we did. Hey, what do you know? We got it. Okay, so now let's move on and do one like that. This is actually an easier one. Look at these lines. Those are easier boundary lines to graph. You just have to remember what they mean. Okay, top line. X is less than or equal to 2. So the boundary line is just x equals 2, right? Dashed or solid? Solid. Show me with your arms what that would look like. Yeah, good, because it's x equals, so it has to go through the x-axis. That's what a vertical line would do, is cut through the x-axis, right? Okay, so this is a really easy one to graph. Solid boundary line, it crosses the x-axis at what value? 2. And then I just need to pick some other point that's vertically aligned with that one. Okay, now am I going to shade, you guys point with your fingers, where am I going to shade if x is less than the boundary line? Yeah, I'm going on the left side, aren't I? It's a vertical line, so I can't go below or above, but it's an x equals anyway, right? X is the horizontal variable. On the x-axis, where are the lesser values? To the left, right? So we're shading to the left. So it's just somewhere over there. Okay, now what about the other line? The boundary line would be y equals -4, right? Show me with your arms what that looks like. Yeah, that's horizontal, isn't it? Because it's got to cut through the y-axis. Very good. And it's solid or dashed? Solid. Cuts through the y-axis at what value?
-4.
Okay, and then I just need another horizontal point. There you go. And oh, look, it broke my paint bucket because it was right on the line. So I got to move that thing. Where do I want to move it? Right there?
No, up.
Above. There we go. Because I want to be to the left of the vertical line and above the horizontal line. So I want to be right in there. Agreed?
Yeah.
Okay, all right. Yeah. Yeah.
Why didn't you put the dot right on -4 on the y-axis versus?
Why didn't I put the dot right on -4?
Yeah, no, why didn't you?
I did. Did I not?
No.
Like on the,
Oh, did I miss it? Did I put it not on the y-axis?
no, because you put it right, you put it
Right on the
to
intersection.
-4 instead of at -4.
Oh, okay, when I made it though, here, I'll go back to it. So what I did when I built this thing, what I did, I don't think I can go back into it anymore, but when I built that horizontal line, I put one point there and I put one point like over there somewhere.
Oh.
And it just, I don't know why it doesn't show them anymore, but yeah,
Just click it.
yeah. And then once I use the points to generate the line, they just go away.
Okay.
Yeah. Okay, fist to 5 on those. Good stuff. Okay, we're done with that part of the test. Now we're on to the more recent stuff. So this is probably, even though it's harder material, you're probably more familiar with it. So the only two parts on test 5 is applications and then solving linear systems with technology. That's it. That's all it's about. So let's go through a couple of these. Application here. One number is 4 more than a second number. 4 times the first is 12 less than 6 times the second. Find the numbers. Well, how many numbers are we talking about? 2. So I only need 2 variables, call them x and y, right? So they're just going to be the first number and the second number. Okay? How many equations do I need? 2. Okay, so then the first equation must come from the first sentence. One number, well, what's one number? X is, what's is mean? Equals 4 more than a second number. What's the second number?
Y.
Y. So what's 4 more than y?
+4.
Y plus 4 or 4 plus y, either one. Okay, good. So then the first sentence is giving us that equation, isn't it? X equals y plus 4. Everybody agree? Okay. We need one more equation. What about the second sentence? 4 times the first, what is that?
4x
Okay, so all that's 4x is
equals
12 less than 6 times the second. What's 6 times the second?
6y minus 12.
There you go, 6y minus 12. Okay, so then we get that from the second sentence, agreed? So then once you set up the system in this test, you don't have to solve it, right? You just let technology do that. So what would be the easiest way to probably do this one? I would just put it in graphing because it's not in standard form. We could put it in standard form, but I could just type it in just like this into Desmos graphing, right? So let's try that.
They probably deleted that
Yeah, probably. Okay, so if I just go into Desmos graphing, my first equation is the red one. So it's just going to be x equals y plus 4. There it is. Second equation is the blue one, 4x equals 6y minus 12. Okay, and then if we started from scratch, it would look just like that. So what would I need to do to get my solution? What would I have to do, everybody? I got to find the point of intersection. How am I going to do that?
Zoom out.
Got to zoom out. Yep, I'm just going to zoom out until I can see that point of intersection. There it is. Remember, if I click on that little, dot or that little, button that was there, let's make that a different color. How about? Then it gives me the ordered pair right over in my list, and there it is. So what are the numbers?
18 and 14.
18 and 14. Okay, there it is. Okay, fist to 5. How are we doing? Good? Okay, we saw one very similar to this. A 6,000 seat theater has tickets for sale at $25 and $40. How many tickets should be sold at each price? So there's the question that's being asked. Those are the unknowns, right? I want to know, they're asking how many tickets should be sold of each price range, right? So what are my variables then? X is?
25, otherwise 40.
But what about it? 25, I need to know what units are we talking about here? Number of tickets, right? So X is number of tickets for sale at 25 bucks. Y is number of $40 tickets, right? Okay? How many equations do I need? Is there a simple X plus Y equals equation here? What is it? If X is the number of cheap tickets and Y is the number of expensive tickets, how many total tickets are we supposed to sell? Oh, there it is, right? So there's my X plus Y equals equation right there. Okay, it's a sellout performance and it's a 6,000 seat theater, so we know we're selling 6,000 total tickets. Okay? The other equation is a little bit trickier, right? The other equation is the money equation. Okay, so we know if we want to generate a total revenue, $181,500 in ticket sales, I want you guys to raise hands here and think about how could we come up with an equation there? I need to have dollars on both sides. What do you think?
25x plus 40.
Perfect. There you go. The equation is going to be 25x plus 40y equals $181,500, right? So we're trying to have dollars on both sides. What does 25x really represent?
The number of tickets sold.
Well, okay, X is the number of cheap tickets. $25 is the price of each ticket. So what does 25 times X really mean?
25
Times the amount that they cost.
Okay, good. So it's the total amount that we're generating by selling the cheap tickets, right? Because the price of each ticket times the number of tickets gives us the total revenue, doesn't it? Right? So we could just recognize that this is dollars from selling X cheap tickets, right? And what's 40Y? Yeah. $40 per ticket times Y tickets, that's the number of expensive tickets. Isn't this whole thing right here just the dollars from selling Y expensive tickets? Does that make sense? Okay, and there's our system. How would we probably solve this one?
Matrix.
Probably matrix because it's in standard form. Okay, so we'll go to the matrix calculator. So I need a new matrix. How many rows? Show me with your fingers, everybody. How many rows? 2, because there's 2 equations. How many columns? 3. Always one more column than rows, right? So what are the numbers, the coefficients in the top? 1, 1, 6,000. Yeah, 1, 1, 6,000. Next row.
25, 40.
Oops, yeah, I do, don't I? 181, 500. Okay, good. Okay, and then I do enter, and I do RREF A. Good? Okay, everybody good with that? No, I just paused it for a second. So this is the x equation, right? So this is the one that's telling us, being as that's x, it's telling us 3,900 of the $25 tickets, because that's what x was, right? Number of cheap tickets. This was our y equation, so that's telling us 2,100 of the $40 tickets. Okay, good. And see if we can get in. Oh, we're going to be pressed for time. See if we can get one more in. At least set it up. So then what we'll do tomorrow, we'll just wrap up the last couple really quick problems. If you want to do a freebie test, you can. Otherwise, you have tomorrow to work on finishing your review up, and you can test like Wednesday, Thursday. Okay? All right, there's going to be one of these on the test, one of these percentage problems. So you got to be able to get through one of these. So let's at least start this here. How many liters of each of a 40% antifreeze solution and an 80% antifreeze solution must be mixed to make a total of 8 liters of a 50% antifreeze solution? So does everybody agree here that X is going to be the liters of 40% solution, right? And Y is equal to the liters of 80% solution, right? There are our variables. I'm going to call it quits there because I don't want to get started on this one and then not finish it. So we'll do this one tomorrow and then just a couple quick matrix calculator ones and we're done.